The folks have a pen and paper?
Yes, sir. I start with mine.
Okay. So we're just going to write some notes about vectors now. Alright, let's go. Scalar quantity has a magnitude only. Magnitude. I wish to look at the word magnitude. Magnitude only. A distance, sorry, a distance of 10 kilometers is a scalar quantity. Quantity. So whenever we talk about the distance, we're talking about a scalar quantity. So distance itself is a scalar quantity. We call it a scalar quantity, right? So let's say magnitude, we're talking about the 10 kilometers right there. Good. Temperature, and the mass are other examples of scalar quantities. We have 10 minutes. Remember, all this don't read again. Quant quantities. All right. Good. So these only have the temperature only have magnitude. So they will say 10 degrees Fahrenheit, 10 degrees Celsius, mass 1,000 kilograms, etc. So those are, so when you talk about scalar quantity, you talk about mass, temperature, distance, etc. Now, another form of quantity is vector. You have the vector quantity now. And note these quantities are things that are measurable. All right. So a vector quantity has both magnitude magnitude a vector quantity has both magnitude and direction. A displacement of 10 kilometers due north. So that's our direction, right? Due north. So now it's moving in another direction, right? So it tells you that it's traveling at a distance of 10 kilometers in another direction. And you know, pilots and sailors will tell you that, right? So that's the difference between a magnitude and a scalar quantity. Sorry, a vector quantity and a scalar quantity. That one has a direction and the other doesn't. So we talk about displacement, an example of a vector quantity. So it has a magnitude has a magnitude 10 kilometers and direction due north. All right. So vectors in the what we're looking at now in terms of vectors, you will have both direction and magnitude to look at. And therefore, a vector, sorry, and is therefore a vector, sorry about that, and is therefore a vector. Force and acceleration are other examples of vectors. You might be asking, how so? Now, force, remember, say force don't just happen just so, it act in a particular direction, and the force itself can be measured, right? It acts in a particular direction, and it can be measured. Somebody could be pulling something to the west. That is a direction, but the measurement, the strength that is used to pull the person, that's where you get the magnitude. So force in itself is a vector. All right. Let me know when you finish writing this off. So we'll look at the definition. So now we will be looking at the representation of a vector. How is a vector represented? All right. How is a vector represented? All right. Okay, Nicole, finish writing. Cheryl, finish writing it. Alright, so alright. So basically we have an idea of types of vectors, scalar, sorry, type of quantities rather, scalar quantity and vector quantity. Alright. Oh, I will be representing the vector now. So now we're going to be looking at representation of a vector. How do we represent a vector? There's a question here. Let's write a little brief note. A vector quantity can be, and this says can be, so it means it can, it's not just one way alone, right? Represented by, when you see the word by, it just suggests how something is done. By a directed line segment. By directed line segment. So let's draw our directed line segment. Um, mhm, mhm. Yeah, so let's draw a line segment. Now this itself is a simple line segment, but it's not a directed line segment. It's just a line segment. Now since we're on line segments are basically a straight line, not necessarily a straight line, because you can have curved line. But the feature of it, the main feature of it, is that it has two ending points. There's one here and the other here. Normal is called the starting point. It's called the ending point right here. But but what makes it now a directed line segment now is the arrow. So this arrow is suggesting that it's moving in this direction. Good. If I drew it another way, it will suggest it moving in the other direction. So this now, without this arrow here, it cannot be called a directed line segment. But with the arrow there, it's called a directed line segment. Okay? Alright, so when you relog in, we'll continue on this.